Hey everybody, Mr. Plant here, and welcome to my kitchen counter of physics. Today I'm going to run you guys through a real life example of the lab we're doing virtually in class today. So what I have is kind of a crazy setup. I had to find random objects. So this is a harmonica, that's 100 grams exactly, and this is a Game Boy Color with a piece of paper taped to it, complete with Pokemon Yellow. That's just like 204 grams, so just a little bit over 200 grams, close enough. And what I can do is I can set it up on my setup I have here, and when I let go of it, it'll drag it across the table. Now the difference here is that I can include friction with this, and I can measure it in a different way than using the computer. Instead I have a LabQuest, which is kind of a handheld computer. And it's just going to record data for me. And then I have this motion detector, which if you listen closely, you can probably hear it clicking. It's using essentially what is echolocation. It makes a click, that sound wave gets sent out, it bounces off of, in this case, the paper of my Game Boy Color, and comes back to the sensor, and it has uses the computer to figure out how long that took to tell me how far away the object is. And as I let this experiment go, this will give me a position versus time and a velocity versus time graph, which means we can find the acceleration if we just look at the slope of the velocity versus time graph. So let's get this set up and let's see what we get. Okay, so I had to run it a couple times to get some good data. I had to kind of tinker with the sensor and make sure it was aimed correctly. But now what we have is, if we look at our graph, is I get a position versus time and a velocity versus time graph. And I know that the slope of velocity versus time is my acceleration. So I can actually have this computer do that for me. So I'm going to go to Curve Fit. And I'm going to tell it I want it to be a line, and the slope of that line, that m value right there, that is my acceleration. So our acceleration this time was 1.5872. So we're probably, with the accuracy we have, we could probably call that 1.59 meters per second squared. Now I can also find the coefficient of friction between my Game Boy and the counter, and that coefficient of friction is just a fancy way for us to figure out how much friction is pushing back against this. I went through and did that off camera, and it is 0.3. It should be up on the slides coming up, but in case you want to write it down now, it's 0.3. And let's see how far off our estimated answer was. See you guys.